This lesson is on the equation of a circle, and actually more specifically the equation of a circle centered about the origin. When we are dealing with the equation of a circle centered about the origin, the equation is written in the form of x squared plus y squared equals r squared, where x and y are any point on the circle and r is the radius. So if we look here at the circle that I have, what you'll notice is that I can actually just determine the radius by counting out. So if I go 1, 2, 3, 4, 5, you can see that I have a radius of 5. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I have the radius of 5. So technically speaking, my equation here would be x squared plus y squared equals 5 squared, x squared plus y squared equals 25. So what you may also have noticed if you've looked at what the distance formula is for, or the length of a line segment, or the distance between 2 points, really this equation is the same thing, because the radius is a distance, but it's the distance from the origin to any point along the circle. So if I was actually going to calculate the distance using the distance formula, you'll see how this will look the same. So we know that the distance is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So my distance, if I'm going to choose, I'll actually choose a point. I'm going to choose this point here, which is the point 4, 3, from the origin, which is 0, 0. So this is x1, y1, x2, y2. So my distance is, whoops, let's get rid of this kind of weird line that kind of got through there. So my distance is x2 minus x1, which is 4 minus 0 all squared, y2 minus y1, which is 3 minus 0 all squared. So my distance is equal to the square root of 4 squared plus 3 squared. So my distance is equal to the square root of 16 plus 9. So my distance is equal to the square root of 25, which is 5. So what you'll notice, again, so just looking at what we had here from the previous one, my distance is 5, and if I use the distance formula from the origin out to here, it is also 5. So really the equation of a circle centered about the origin is essentially the distance formula. It's just the distance formula. So what we'll do now is we'll do a couple of other examples where you'll have to determine the equation of the circle centered about the origin, and then also some applications such as determining the what the radius of a particular circle is, given some information. Okay, now it's time to again do some examples. So for each point, determine an equation for the circle centered at the origin and passes through the point. So for the first one, we have the point -3, -6. So again, the equation of a circle is x squared plus y squared equals r squared. And so we need to substitute in our point to find out what the radius is. So we have minus 3 squared plus minus 6 all squared equals r squared. So we have 9, and 6 squared, or negative 6 squared, is 36. So 9 and 36 is 40, whoops. 9 and 36 is 45. So that now we have the radius. So since we have the radius squared, we can write an equation to represent the circle, which is x squared plus y squared equals 45. So this here is my equation, where 45 is the radius squared, and it is centered at the origin. If I asked you to find out what the radius is, you just have to take the square root of 45. Okay, so let's do the next example. Well, actually, what you should be trying the next example. Pause the video, try it on your own, and then play it when you want to check your answer. Okay, so now you should have done this, so we're just checking our answer. So we have x squared plus y squared equals r squared. So I'm substituting in my information. So I have minus 7 all squared plus 12 squared equals r squared. So I have 49 plus 144 is r squared, and that will be 193. So 193 equals r squared. So therefore my equation is x squared plus y squared equals 193. Again, 193 is the radius squared. It is not the radius. To find the radius, you would have to take the square root of that number to determine what the radius is. So the questions that we should look at now are determining the radius of circles given a certain equation. So in the following two examples, we'll be looking at determining the radius of the following circle centered at the origin. So if we know that the equation of a circle is x squared plus y squared equals r squared, what we can say is that the radius squared will be this number here. So if I know that the radius squared is equal to 225, if I take the square root, whoops, I'm going to erase that. If we take the square root of both sides, we will find the radius. So the radius is equal to 15. Now, in this situation, because there is a perfect square root of 225, then this 15, this is the exact radius. In the example of x squared plus y squared equals 75, so again, this here is the radius squared, so x squared plus y squared equals r squared. Then to determine the radius, we know that r squared is equal to 75. So the square root of r squared is the square root of 75. So the radius is the root of 75. That means that this is the exact radius because 75 does not have a perfect square root. If we take the square root of 75, just getting my calculator going here, so the square root of 75, we have, whoops, the radius is equal to 8.66, and 8.66, this is an approximate radius. So if you have a perfect square root, then you can determine the exact radius will be like we had here in example A, but in example B, where we don't have a perfect square root, the exact radius is what's left underneath the square root sign. And so you would leave it like this if you were asked for the exact radius. If you were just asked for the radius and you were allowed to approximate it, then you could have it and leave it like this. In this situation, it doesn't really matter. One last concept that we should look at are the x and y intercepts of a circle, and specifically about centered at the origin. So if we look at this circle here, what you will notice is that we have two x and two y intercepts. I have an x-intercept here, and I have another x-intercept here. So those are my x-intercepts. I have two. The circle crosses the x-axis twice. And I have two y-intercepts. I have y-intercept here, and I have a y-intercept here because it crosses, the circle crosses the the y-axis at two places. So if we look here, this is the same circle that we started with, and the equation of this circle that we determined from at the beginning is x squared plus y squared equals 25, because the radius is 5, and so 5 squared is 25. If I wanted to algebraically determine what the x and y intercepts are, we know that the radius, because this is centered at the origin, so we have our circle centered at the origin, we know that the radius, if we knew the radius, we could go that distance along the x-axis in both directions from the origin to determine what our two x-intercepts are. And it's the same idea for the y-intercept. If we travel that distance along the y-axis in both directions, the positive direction and the negative direction from the origin, we can determine what the x-intercepts are. So fundamentally, if we figure out what our radius is, we will know what our x and y intercepts are. So this one here, if I just, because I drew it, this is 5, 0. This is 0, negative 5. This is negative 5, 0. And this is 0, 5. What all of those intercepts have in common is the radius. So if I know that the radius squared is equal to 25, I know the radius is the square root of 25, so my radius is 5. Therefore, algebraically, we know that from the origin, we can have our x-intercepts, we'll have 2. We'll be at 5, 0, and negative 5, 0. And the y-intercepts at 0, 5, and 0, negative 5. So finding the x and y intercepts are fairly straightforward for a circle because we know we have two of each. And so our radius will help us determine what our x and y intercepts are because we know it's centered at the origin in this circumstance. And so all we have to do is from the origin move out the radius along the x and y axis in all directions to determine what the x and y intercepts are. What we'll do now is work through a couple of examples where we will determine the x and y intercepts of a circle centered at the origin, where we don't have a graph to represent the circle. So right now we'll just do the first one. So we know that the radius, we're trying to find the x and y intercepts. We know that if we know the radius, we are able to move that distance from the center out on the x and y axes, and that will bring us to the x and y intercepts. And don't forget, we will have two of each. So if I know the radius squared is equal to 17, then the square root of the radius squared will give us just the radius. So we have 17, the square root of 17. Now, in this situation, because we actually have both a positive and a negative square root, that means that we can move either, if we're looking at the x-axis, if we're going from the origin, we're going to move to the left the square root of 17 units to get to the x-intercept, the negative x-intercept. And we have the positive square root of 17 if we move right 17 along the x-axis from the origin, then that will give us the positive x-intercept of the circle. And then the same holds for the y-axis, positive moving up the square root of 17 units, and then the negative square root moving down the root of 17 units to get to the other y-intercept. So as I mentioned previously, because we don't have a perfect square root, this is an exact number. And we don't need to take the square root and round it because this will work perfectly. It's an exact number. So we have our two x-intercepts. So x-intercepts. And those are at the root of 17, 0. And minus the root of 17, 0. And then we have our y-intercepts at 0, the positive square root of 17, and at 0 minus the square root of 17. And those are x and y intercepts for that particular circle. In the case of B, where we have x squared plus y squared equals 144, if you want, you can pause this right now and try and work through it yourself. I would prefer you to do that, and then play it to see if your answer matches the answer that I'm about to figure out. So here, again, we have the radius squared is equal to 144. So the radius, I'm just going to erase that. Don't know why it does that. So the radius is equal to the square root of 144. And again, we have a positive square root and a negative square root. So that means it will tell us what distance we are going to travel, either left and right, from the origin for the x-intercepts or up and down from the origin for the y-intercepts. So our radius is plus or minus 12. So that means our x-intercepts from the origin are minus 12, 0, so that's to the left, and 12, 0, which is to the right. And our y-intercepts are 0, 12, so that's positive up, and 0, negative 12, which is moving down from the origin. So really, these are all of the skills that you're going to need for circles, you need to be able to determine the equation of a circle. You need to be able to determine what the radius of a circle is from an equation, what the x and y intercepts are from an equation. And with that, you should be able to answer all of the questions that you may have regarding circles, because we have a perfect square root.